दोस्तों, वेलकम टू माय चैनल। तो आज हम आपके लिए लेकर आए हैं मैकेनिज्म ऑफ ऑर्गेनिक रिएक्शन। ओके, तो इस टॉपिक के अंडर जो टॉपिक हम लोगों को पढ़ना होगा वो ये सब है। देखो, मैं 3 कैटेगरीज में डिवाइडेड कर दिया है। देखो, फर्स्ट वन इज़ टाइप ऑफ रिएजेंट्स, होमोलाइटिक एंड हेटेरोलाइटिक क्लीवेज, टाइप ऑफ ऑर्गेनिक रिएक्शन। ओके, एंड सेकेंड वन इज़ रिएक्टिव इंटरमीडिएट, कार्बोकैटायन, कार्बोनायन, free radical, carbene, arynes and nitriles. Next topic is different type of addition, substitution, elimination reaction. इनके अंडर जो रिएक्शन है SN1, SN2, SNI, E1, E2, E1, CB। ओके, तो ये सब हमारे सिलेबस में है, तो ये सब को आप लोगों को पढ़ना होगा, देन MCQ प्रैक्टिस करना होगा। ओके, तो चलो प्रैक्टिस करते हैं। पहला क्वेश्चन है, which one is most reactive towards SN1 reaction? ओके, सो वी नो दैट SN1 का जो इंटरमीडिएट है वो कार्बोकैटायन है, एंड उसके कार्बोकैटायन की स्टेबिलिटी हम कंसिडर करते हैं पहले रेजोनेंस, ओके, प्लस आर, देन हाइपर कंजुगेशन, देन इंडक्टिव। ओके, तो इनके बेसिस पे हम कार्बोकैटायन की स्टेबिलिटी को देखते हैं। सो देखो, जो आंसर यहाँ पे होगा वो है ऑप्शन सी, बिकॉज यहाँ पे जो कार्बोकैटायन जनरेट होगा उसमें सबसे ज़्यादा स्टेबिलिटी होगा। ये एक pH यहाँ पे और एक pH यहाँ पे। ओके, तो दिस pH एंड दिस pH फिनाइल ग्रुप बेसिकली रेजोनेटिकली स्टेबिलाइज द कार्बोकैटायन, एंड CH3 ग्रुप इज हाइपर कंजुगेटिवली एंड इंडक्टिवली stabilize the carbocation. Okay, so here the correct option is option C. Next question, SN2 mechanism proceeds through intervention of. Okay, so here we know that in SN2 mechanism what happens, like give an example, RCl, if we give this OH minus, then which R is formed. Okay, backside attacks from this group and the leaving group is leaves, and this process is a concerted mechanism follows. Okay, so here carbonium ion or free radical or carbon ion is not generated, it is a transition state follows. Okay, so here the correct option is option B. Next question, phenol उसके अंदर जो reagent given है CHCl3 alcoholic KOH, product is orthohydroxybenzaldehyde. Okay, for this reaction the intermediate involved is a singlet carbene, triplet carbene, both or none of this. Okay, so we know that if we consider the free radical, if the free radical, carbon free radical attached to a heteroatom which have lone pair of electron, okay, this is considered to be a singlet carbene. Or if the carbene is attached to a bulky group such that this type of group, okay, so this bulky group, if carbene is attached, this is triplet carbene. Okay, so here we know that in this is reaction of Raman-Tillman reaction. In this reaction CCl2 carbene is generated. Okay, so here heteroatom chlorine is attached and which have the lone pair of electron, so the carbene is singlet carbene. The answer option is A. Okay, next question, identify the following reaction. Okay, here this substrate is given and from backside which minus is attacked to this, and this product is obtained. Okay, so here inversion of configuration occurs. So we know that in SN2 reaction inversion of configuration occurs. Okay, so here the correct option is option D. Identify the following reaction. The substrate is given, that is a bromide, and the base is NO8 is given. Okay, and here the 3 types of alkenes are formed. One is major and one is minus and one is 1%. Okay, so we know that in this case if NO8 is given, then SN2 E2 mechanism is followed. Okay, and as this product is E configuration, so this is major. Okay, and as it is Z configuration, so it is minor, and this is the ZZ product, this is the Hofmann product, and this is a these two are Sitze product and this is Hofmann product. Okay, so here the reaction is to elimination. Okay, here how we write this mechanism? I will write this. Here one hydrogen is given, OET minus is there. Okay, this will abstract the hydrogen and this bond will give to this and the bromine is leaves here. Okay, so here this will form as well as this also is formed, and if we consider the hydrogen of 1 minute, if we consider the hydrogen from this, okay, then the product is this is obtained. Okay, and it is Hofmann product, less substituted product. Okay, so here the correct option is option B. Next one, similar type of reaction, major product of this reaction. We consider this reaction as an E2 elimination. Okay, so here A and B both are formed, but the major product is A. Okay, it is also the same mechanism follow. If we consider as there is given H plus of this reaction, okay, this is carbocation formed and this will leave out, and here this is, okay, this type of product is formed which is major. Next, identify the following reaction. It is also here as the OH group is present in one pH group to CH3 group, so here the carbocation is generated, and the carbocation is like that. Okay, so this is a 3-degree carbocation, and as well as it is a benzylic carbocation, so here E1 mechanism is follows. Okay, so option A is correct. Next, this is the formation of a Demjanov reaction, and what type of reaction intermediate involved in this reaction? As this is a if we given HNO2 or nitrous acid, then here a carbocation is generated. Okay, so here the option is carbocation. Okay, then if we draw the mechanism, let's see. In H2, if we given HNO2, then here a carbocation is formed. Okay, or you can see that, right, that this is N2 plus. Okay, then a nitrogen gas is evolved and a carbocation, secondary carbocation is formed. Wait, this type of carbocation is formed, and here ring expansion is occurred and 5-member ring is formed. Then water is added from this carbocation and the product is formed. Okay, OH, this is the product. Okay, next, for this conversion A and B intermediate involved in the reaction, which one is major? A and B. Okay, we know that it is the type of addition elimination mechanism. So here the intermediate formed is benzene intermediate, and here A is the major product. Okay, how can we write this? At first we know that there are two acidic hydrogen, this one and this one. So if we abstract one hydrogen by NH2, both are equivalent. Okay, so here benzene intermediate is formed. Okay, now next step is NH2 attacks from where? This position or this position. Okay, so here if we attacks by this position, then negative charge is on this in that position and which is stabilized. Okay, so option A is correct. So option A is formed as a major product, and here the correct option is benzene and A. Okay, intermediate is benzene, and the answer is option C. Next question, CH3 and CF3 hybridization of the both radical. We know that CH3 is an sp2 hybridized. Okay, CH3 plus, this is radical, 1 minute. CH3 dot is an sp2 hybridized, and CF3 dot, it is an sp3 hybridized. Okay, so here the correct option is option C. Which statement is incorrect? First one is carbon free radical are odd electron species. Carbon free radicals are diamagnetic and highly reactive. Homolytic bond fission of covalent single bond gives rise to carbon free radical, and next free radicals are neutral species. If we consider a free radical, that is CH3 dot. Okay, so here we know that this happen one odd electron. Okay, and it forms by the cleavage of CH3. Okay, homolytic cleavage. And next, and it is also an neutral species. Okay, so the option is carbon free radicals are diamagnetic and highly reactive. The diamagnetic word is not for this. Okay, it is in paramagnetic species, so option B is the incorrect here, or I will say it is the right answer. Okay, next, write the stability order of the कार्बोकैटायन. जो हम पहले बोला है कि कार्बोकैटायन के स्टेबिलिटी के ऑर्डर हम देखते हैं. पहले देखते हैं रेजोनेंस, देन हाइपर कंजुगेशन, देन इंडक्टिव इफेक्ट. ओके, these are the factors. Okay, so if we calculate here the stability is we can consider by hyperconjugation and inductive effect. Okay, the first one is from A, for this compound A, here 4 hydrogens are there, and so 4 hyperconjugation structures are possible. 4 alpha hydrogens are there here, 3, 2 and 2, so here 7 alpha hydrogens are present. Here also 4 alpha hydrogens are present, and here 1 alpha hydrogen is present. Okay, so and for this 1 and 3 there are 4 alpha hydrogens are present, but in case of 3 there are CH3 group from 3 carbon later. Okay, so here inductively it is more stabilized. So at first B is more stable, where is B? B is more stable, then C, then A, then D. Okay, so D is correct answer. Next, write which is more stable carbanion. Okay, so here the correct option is option E, because in this case there is banana type bond is formed, or dancing resonance is possible. Okay, here aromatic stabilization is occurred, and here their resonance stabilize, and here inductively stabilize the carbanion. But as there is dancing resonance is possible, so it is more stabilized than aromatic stabilization. Okay, so here the correct option is option E. Next, write stability order of carbanions. Okay, we know that if we consider, then aromatic are more stable, then minus R, then minus H, and then minus I. Okay, these are the stabilization factor of carbanion. Okay, so here the case for the first compound, this is the 6 pi electron. Okay, so it is aromatic carbanion, and here it is sp carbanion. So in the negative sp carbon, the carbanion is more stable, and here it is sp3, and this is resonantly stabilized, minus R effect. Okay, so here the correct option is at first A, then B, then D, then C. Okay, so here the correct option is option B. Okay, so thank you.